It is given here that rate constant is numerically the same for the three reactions of first, second and third order, and the correct order of rates of these reactions at various concentrations are. Now if we take this reaction A giving rise to product, if we consider this one as a first order reaction, then what will be the rate equation? We can write like this: R1 is equal to K into concentration of A. And if this is the second order reaction, how we will write the rate equation? R2 is equal to K into A square. And for the third order reaction, we can write the rate like this: R3 is equal to K into A cube. Isn't it? It's clearly mentioned that the rate constant is numerically the same for all these three reactions. So, as K is the same in all these reactions, if we consider that concentration of A is equal to 1, now tell me what happens. When concentration of A is 1, A power 1, A power 2, A power 3 all becomes the same value, that is 1. So now R1 is equal to K, R2 is equal to K and R3 is equal to K, isn't it? It means R1 is equal to R2 is equal to R3. So this is the case when the concentration of the reactant is equal to 1. So definitely this should be there in our final answer. Let's see the other case where if the concentration of A is less than 1, then what happens? Let me take this value as equal to 0.1. So in this case it becomes K into 0.1, and in this case it becomes K into 0.1 into 0.1, and here it is K into 0.1 cube, isn't it? So in which case the rate is more? Definitely here, isn't it? So R1 is greater than R2 and this is greater than R3. So it's clearly mentioned that we need to find out the correct order of rates of these reactions at various concentrations. So here we took A as equal to 1. So we are getting R1 equal to R2 equal to R3. If A is less than 1, we are getting this relation which is there in option B. And we can take the other one also. If the concentration of A is greater than 1, then what happens? Suppose we take the concentration of A as equal to 2. Here it becomes K into 2, and here it becomes K into 2 square, that is 4, and here it becomes K into 2 cube, that is K into 8. It's very clear that here the third rate is greater than R2, which is greater than R1. Means R1 is less than R2 less than R3. So all these three are the correct whenever we are taking different concentrations. So it's clearly mentioned that we need to consider various concentrations of the reactants. So our answer becomes option A, B as well as C.